And we're back. It's time to sort it out. We have orbital motion of a satellite. Here we have a satellite of known mass and known altitude above the planetary body. So we want to figure out what is going to be its orbital speed and its period in hours. So how long it takes to complete a revolution in hours. So let's start thinking about it this way. The centripetal force on this object comes from the force of gravity. So our free body diagram, super simple. And then plug in what we know for both of those using Newton's law of universal gravitation on the right. Now you can start to simplify that. We will notice that the mass of the satellite, which I'm calling m1, cancels out because it appears on both sides of the expression. Very important. So that means that the mass of the satellite does not actually influence its orbital speed. Then continue simplifying and solving for v. But we do need to think about this. R, when you're using law of universal gravitation, that's the distance between the centers of mass, which could be the radius if the object was on the surface, but because it's above, we need to include the altitude. Check the drawing for that. And then we want to use the gravitational constant, big G. There it is there. Include that in your calculations. So that will give us our speed, but then we want to find the period. In circular motion, the velocity is 2 pi r over t, circumference of the circle divided by the period. Go ahead and arrange that for t. Remember that's the period in seconds. Then, again, we want to include the altitude. And now that we know the speed, which we found in the first part, we can figure this out. And the way that the units work out, this is period in seconds. So you can use this process of conversion. We are going to end up with a period in seconds. So if we put seconds on the bottom and minutes on the top, then minutes on the bottom and hours on the top, those will cancel to give us the right units. So that's how you can see the conversion working out there. And so that's what we need for this question.